Welcome to the dojo. Today, we are stepping onto the mat to completely transform your approach to Cambridge computer science questions. We are going to specifically focus on the notoriously tricky topic of bit streaming, but the strategies we uncover today will elevate your game across the board. For those of you tackling syllabus 9618, or really anyone working through syllabus codes 0417, 0478, 0983, 0984, or 2210, you already know that understanding real-time and on-demand streaming methods is an absolute beast. It is not just about memorizing definitions from a textbook. It requires a masterclass level of precision, strategy, and mental agility. We want you to adopt a core concept today: flow like water. You need to be able to adapt your problem-solving style to literally any question the examiners throw at you. To set the stage, let's look at a classic challenge. Imagine a real Cambridge computer science past paper question, let's say from a tricky 9713 paper. We usually see two types of students tackle this. First, there's Alex. Alex is brilliant but overloads every answer with raw computer science facts, completely missing the analysis part. The page is just covered in red ink because it doesn't answer the actual prompt. Then we have Sam. Sam gets anxious, rushes through the paper, and totally misses the command word requirements. Sam's answer is a mess of half-thoughts. Today, we are going to fix both of those approaches. Our agenda today is highly structured to guarantee efficient learning. We will be covering the core principles, the procedural framework, algorithm evaluation, and finally, the top examiner warnings. Let's start with Section 1 and lay down the foundational principles. Let's redefine what we are actually studying here when we talk about bit streaming. When we are evaluating a live, real-time broadcast of a massive sports match and comparing it against streaming an archived, on-demand movie, we aren't just talking about user experience or buffering screens. The Cambridge syllabus emphasizes that top-performing students demonstrate a deeply connected conceptual understanding. You absolutely must be able to use systematic analysis and evidence-based reasoning. Think back to Alex, the student who just lists facts. If Alex gets a question on this, they might just write down the definition of bit streaming. But that is not enough. This means when you are presented with an unfamiliar context in an exam, your foundational understanding of these protocols has to transfer seamlessly to solve the specific problem at hand. It's about adapting your knowledge to the context. Because of this, raw memorization is no longer going to cut it. It won't secure you top marks. The assessment objectives in Cambridge exams are meticulously designed to target 3 distinct cognitive domains. You need the base knowledge and understanding, absolutely, but you also desperately need application and analysis. If you only memorize what bit streaming is without analyzing how an algorithm handles the data transfer efficiently, you are leaving major marks on the table. To hit these domains, top students use something called the PEEL framework. That stands for point, evidence, explanation, and link. You make your point, you back it up with evidence from the scenario, you explain the technical computer science mechanics behind it, and you link it right back to the command word in the question. Think about Sam, who rushes and misses command words. If Sam used PEEL, they would be forced to slow down and actually hit all 3 of these cognitive domains perfectly. Moving right into our second section, let's look at the actual procedural playbook. Okay, this is absolutely crucial. We need to talk about the method mark strategy. It is vital to remember that examiners actively award marks for your data interpretation and your programming processes, not just your final answer. When you're calculating data transfer rates for a real-time stream or manipulating binary representations, showing your step-by-step algorithmic thinking is what secures your grade. Even if you make a minor calculation error at the very end, showing your work saves you. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, don't miss out on these strategies. Now, back to method marks. Examiners want to see your brain on the page. They want to see the sequence of your logic. If you just write down a number, you get 0 method marks. It's like doing a math problem in your head. It doesn't matter if you're a genius. The examiner can't grade what they can't see. Let's build this into a reliable system. Whenever you face a bit streaming question, deploy this 5-step framework. 1. Deconstruct the exact requirements. 2. Extract your relevant data, like bandwidth limits or binary values. 3. Select your analytical framework. 4. Execute it using clear mathematical notation. And 5. Present your solution using rigorous technical terminology. Remember Alex's messy, fact-heavy paper covered in red marks? If we apply this framework, we see a complete transformation. Those red marks turn into green check marks. Instead of a random brain dump, Alex now deconstructs what the question actually wants, extracts only the necessary bitrate data, and executes a targeted answer. It literally transforms a failing grade into a top-tier response because the knowledge is finally organized in the way the examiner's rubric demands. Taking that a step further, for those really high-mark essay-style questions, you need to rely on this advanced deconstruct, solve, evaluate loop. Identify the given info, break it into logical steps, solve systematically. But then, and this is where top students really shine, check your answer for reasonableness. Does the resulting transfer speed actually make sense for a massive on-demand video file? Finally, justify your recommendations. Let's look at our rusher, Sam. By using this exact loop, Sam's rushed, half-baked answers transform into methodical, green checkmark masterpieces. If a question asks you to recommend a streaming method, your justification is where the highest cognitive domain is assessed. You can't just say use real-time streaming. You have to justify it based on the logical steps you broke down earlier. This right here is your computer science success blueprint. Let's move to our third section. How do we evaluate the quality of an algorithm implementation? Higher-order assessment objectives demand that you don't just write an algorithm, but that you deeply, critically evaluate it. When looking at algorithms related to data streaming, you absolutely must evaluate 4 critical elements: time complexity, space complexity, edge cases, and the overall effect on performance. Meaning, you have to sit back and ask yourself, how fast does it run? How much memory does it consume? What happens in unexpected scenarios? This is exactly what the examiners are hunting for. If you are comparing how a real-time streaming protocol handles buffering versus an on-demand protocol, you have to talk about space complexity. How much memory is that buffer taking up? If you ignore these 4 pillars, you are handing in an incomplete analysis. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's look at this table. Here is your literal blueprint for comparative questions. When you are asked to evaluate alternatives, your analysis must explicitly include both similarities and differences. You have to use comparative connectives like whereas or conversely. Back up each comparison with evidence from the text and draw a concrete conclusion on the relative importance based on the scenario. Without this connective structure, an evaluation answer is just a disjointed list of random facts. Finally, let's dive into Section 4. This is direct intelligence gathered from the principal examiner reports. Year after year, the examiner reports highlight 3 specific, highly repeated mistakes that continually cost students their top grades. Let's make sure you aren't one of them. For this next part, we are going to do an interactive workshop. Get your brains ready because I want you actively participating in this. Think of this as a live challenge. We are going to look at these 3 mistakes, and I'm going to test your ability to spot them and fix them. For our first challenge, a data scan. Imagine a complex computer science chart showing bandwidth fluctuations during a live stream. You'd have exactly 60 seconds to extract the core trend before the timer runs out. Could you do it without panicking like Sam? Welcome to Challenge 2, Find the Flaw. The absolute #1 mistake examiners complain about is providing generic answers. If a question gives you a specific scenario about a hospital streaming live surgical feeds versus an entertainment company offering on-demand movies, your answer cannot just be a textbook definition of bit streaming. Let's say a student writes, real-time streaming is fast. Spot the flaw? Time's up. The flaw is that it has 0 context. The examiner commentary would rip that to shreds. You must link every single analytical point directly to the context provided in the question scenario. Context is king. You have to say, real-time streaming allows the surgical team to receive instantaneous visual feedback, which is critical during a live operation, whereas on-demand would introduce unacceptable latency. See the difference? That brings us to the second major warning and challenge 3, speed writing. Examiners note that, quote, students forget to check boundary conditions and edge cases. When you are designing or evaluating a solution, you must test your algorithms rigorously against the extremes. So you have 30 seconds to mentally draft a perfect PDL paragraph. What happens if the network drops completely during that surgical stream? What if the file size is 0? Overlooking these boundary conditions shows a lack of the thorough testing skills that Cambridge expects. If you aren't writing about edge cases, you aren't thinking like a computer scientist, you're just scratching the surface. The third critical mistake is being too vague. Examiners are actively scanning your paper for precise technical details. Saying it transfers data fast is incredibly vague and will get you nowhere. Discussing the exact bit rate, buffer utilization, and specific network protocols involved in real-time versus on-demand streaming is precise. Never sacrifice technical depth for a simplified explanation. This is where Alex used to fail, dumping facts without technically linking them to the system's performance. You need to be a surgeon with your words. Be precise, be technical, and be incredibly specific about the mechanisms at play. So let's bring our complete system together. By adopting these strategic frameworks, you are guaranteeing yourself top marks. Here are the 3 rules of our cheat sheet recap. 1. Command word decoding. Always start by deconstructing the question loop to structure your thinking. 2. Peel framework application. Make sure you secure those vital method marks by showing your clear, step-by-step algorithmic processes and providing evidence. 3. Time management matrix. Always link your answers to the specific context of the question without rushing. Addressing these examiner warnings head-on is the ultimate difference between an average grade and a top-tier Cambridge result. As we wrap up this masterclass, I want to leave you with a real challenge. How will you apply the deconstruct, solve, evaluate method to your very next past paper question? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here. Keep learning, keep flowing like water, and we will see you next time.